Hello everyone. In this video, we will solve for this differential equation using separation of variable. So this is the first order differential equation because we are working with y prime. It's the first order derivative. So the very first step is to convert this symbol y prime to dy over dx. Okay, I will convert this to dy over dx equal to 0. So the very first step, you want to multiply each of these terms by dx. Okay, so this is dx, so I multiply by dx. So now you see that this is actually cancelled out. Okay, and this side which is equal to 0. So the very next step is to get rid of the y because now you have dx, so you want all of this involving x. That's why you don't want the y. And in this here, you want to get rid of this x to the 4 plus 9 so that it doesn't come with the dy anymore. So what I'm going to do is you are going to divide each term by y multiplied with x to the exponent 4 plus 9. Okay, or you can divide it by 5y. Okay, so what I will do is I will divide it by 5y and multiply with x to the 4 plus 9. To here, I will divide it by 5y. So this is 0, 5y, x to the 4 plus 9. Okay, and divided by 0, it just becomes a 0. So now you see that you get rid of this 5y altogether, and then you get rid of this altogether, and then what you have is you will have the x cubed dx, x to the 4 plus 9, and plus dy divided by 5y equal to 0. So all the variables are separated. Here dx involving all the term with the x, dy involving the term with all the y. So what I'm going to do is I now integrate both sides. Okay, each term of the equation. So now you see this differentiation involving in this integration because you have to let u equal to something. Okay, so you're going to let u equal to this denominators, and you know that since you raise this to exponent 1, so it will be a ln. This is also a ln as well. So this is easy. I can write it right away. So this is 1 over 5 ln of y plus c2. Okay, so what I'm going to do is I'm going to solve for this integration. Okay, so solving for this integration, I will rewrite it like this. Integral of x to the exponent 3 dx, and this one will be x to the 4 plus 9. Okay, the reason I'm writing it like this because I'm going to let u equal to x to the 4 plus 9. Okay, so let u equal to x to the 4 plus 9 immediately after you differentiate. So it's the 3x, it's the 4x to the 3. Okay, because you multiply 4, you reduce the exponent by 1. And plus 9, the derivative of 9 is equal to 0. So now you manipulate this equation. You end up with du over 4 equal to x to the 3 dx. So now this one matching each other, the differential factor matching with this, right? Okay, so what you are going to do next is you are going to write this as 1 over u times du over 4. So now you are going to have 1 over 4 du over u. So therefore it's 1 over 4 ln of u plus c1. Because this one you already have it with the c2. So now it becomes 1 over 4 ln of, you let u equal to x to the 4 plus 9. Okay, so now let's put them together. So therefore the differential equation will be 1 over 4 ln of x to the 4 plus 9 plus 1 over 5 ln of y absolute value equal to c as the final answer. Alright. Okay, so there's few ways you can write this equation. It can be quite a few forms, but to simplify, we just leave it as at this form. Okay, so separation of variable for this equation. What we have done is we convert the y prime to dy over dx. Then you multiply dx to each of this term to have dx as a multiplication or the differential factor for this. And after that, you need to separate the variables by divided by phi y, but the same thing divided by x to the 4 plus 9 as well, to separate the variable at the same time, to have x go with dx, to have y go with dy. Okay, so this cancel out. I end up with this. This cancel out, I end up with dy over phi y. So this one will give me 1 over 5 of ln of y. So this integration is simple. Everyone knows that already. Okay, so the formulas is in fact is u du over u equal to 1 ln of u, okay, plus c. All right. Okay, so this is the formula that we were using. So for this one, it's also a ln, but you have to let this equal to u. You let this equal to u, you differentiate, you end up with this manipulation, the formulas to get to this x to the q dx. That's why you replace that by du over 4, bring a quarter across the integral sign, then you end up with ln of u, and put the two together. That is the solution for this differential equation. Okay, so let's move on to the next one. This one right here. So now you know that solving for differential equation is quite challenging. It needs to have the logic of algebra involved. Okay, so how do we approach this equation? So first of all, you see that you are having dy on its own. Then you have this term in dx, and you also have dx on this side as well. So what we need to do is you want to move this one over to this side of the equation, and you factor out the dx. Okay? Okay, move over to this side of the equation, factor out the dx. So I will have dy equal to 5x squared plus ln of y dx. Then I will subtract this with ln of x squared y and then dx. Okay, so we are going to factor this out, right? So what we do is we are going to have 5x squared plus ln of y, subtract ln of x squared y, everything multiplied by dx. Okay, so let's double check. Alright, so this is what we have. We factor it out. If you multiply this back inside the bracket, you end up with the exact same thing. So now, I am going to ask you to take a look at this two term. Okay, we are going to use the property of logarithm. Okay, property of logarithm. So if you have ln of n, subtract ln of n, this will be ln of m divided by n. Okay, so it's just a reminder. So this is the formulas for property of logarithm. So I'm going to apply that property of logarithm here. So this 5x squared, I leave it the same, but I can write this one as plus ln of y divided by x squared y. Okay, this multiplied by dx. So now inside this ln, I see that that cancel with that. So it's dy equal to 5x squared plus ln of x to the exponent minus 2. Okay, because it's ln of 1 over x squared, so I bring it up to make that into the exponent of minus 2. Okay, so here then I'm going to ln of 1 over x squared, so I can write this ln of x minus 2. Okay, another exponent formula. And now I am going to use another property of logarithm. Okay, use another property of logarithm. That property of logarithm is like this. So if you have a natural logarithm of n to the exponent p, okay, what you can do is you can take p out and you multiply that with the ln of argument n. So in this case, I will have subtract 2 times ln of x dx. Okay, so the reason I'm doing this is because you know that up to this point, I supposed to integrate, okay, integrate both sides. If I integrate this dy, okay, I can figure out the integral of dy. I can figure out the integral of 5x squared, but how do I figure out the integral of ln x to the minus 2? So if you go to this formulas sheet, this formula sheet, you can see that we are trying to find the integral of ln. Okay, so we'll go up and down, up and down. I see here the integral of ln, but I don't have the integral of ln to certain exponent. So I might as well apply that property of logarithm in order to simplify my integrand. So I do that before I make that into an integrand, right? So then I can use this formulas here, formula number 18. Okay, so let's go back to our, so right here, I immediately turn that into a minus 2 ln of x, so I know that if I integrate this, I will be able to just use the straight formula number 18. Okay, so because right here I can apply property of ln. So before I do that, I'm going to write it like this. I multiply dx in. Okay, I multiply dx inside both of these. So when I've done that, I can go ahead and then insert the integral sign for each of this. Okay, so integral of dy, integral of dy. What is the integral of dy? Integral of dy, I can reveal to everyone that this is actually 1 times dy. So what is 1 times dy? Is y to the exponent 0 dy. Okay, so I might as well write this. Okay, so this one will be 5x squared dx. I'm going to integrate this, all of this at the same time. Okay, so add 1 to the exponent divided by the result. So I add 1 to the 0, so I will have y to the 1 divided by 1. So I will just have y plus c1 right here. Right here I should have 5 over 3 x to the exponent 3, add 1 to the exponent divided by the result. And this one I will multiply this by x ln of x minus 1. And this one I might as well put it plus C2, or right here I should put plus C3 here and plus C2 over here. Okay, so right here I should add the C2, subtract 2, add C3. Alright, so each of this integral, after I integrate, I add a constant. Integrate, got a constant. So this is the formula. If you integrate a ln of u du, then what you have is you should have u ln u subtract 1. Okay, so let's double check that formulas. So I'm pretty sure that is correct. Ln ln u minus 1, and instead of u is an x. Okay, so I will have ln x minus 1. Okay, so absolutely correct. And then this question asked me to just solve for the general solution explicitly for y. So I'm going to write y on this side. And then in the end, you know that it's like C2 plus C3 subtract C1. So I would just add that with C. Alright, so let's see. 5 over 3 x to the exponent 3 times 2 times x minus 2 times x ln x minus 1. So the final solution is this. Okay, very good. Alright, I think I end this video right here. In the next video, I will go over a few more solving for differential equation. Okay, so let's just to recap this question. So this one, you see that dx appear on this side of the equation, this side of the equation as well. So the best is to move this over to this side and factor out the dx. Factor out the dx. You see that you apply the property of natural logarithm to get rid of the y, because there's no way that you divide it by y, but you can never get rid of any of this. Okay, you can divide it by ln of y, but there's no way that you can divide it by ln of y to get anywhere that you want. Therefore, the best is to make sure that it stays as a natural logarithm, and then you go from there. Okay, so right at this point you have ln of x to the negative 2, but there isn't any formula involving this. Therefore, you might as well apply the property of logarithm to simplify everything before you integrate. Okay, so quite a lot of algebra involved, and it's a bit complicated. However, it's require the integration skill, and also involving very good algebra skill as well. Alright, thank you.